Okay, for this chapter 2 or chapter proportional equivalent is chapter 1.2. Is we are looking for the proportional equivalences. Okay, proportional equivalences that we learn before this. Okay, okay, we have truth table. Okay, and then we are also uh, namely define the P and Q as a logically equivalent. If P is logically equivalent to Q, we can call it as a tautology. And also, if P and Q are logically equivalent, we write P equivalent to Q. Lah. Okay, before this, in chapter 1, okay, we can see P is equivalent to Q. In the truth table, we can call it as a tautology. Okay, and then we can say also this one, if P and Q are logically equivalent, we can write also P is equivalent to Q lah. Okay, tautology mean all the values are true lah. We have a true, 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 true. Depend on the truth table output. Okay, clear? Is it okay? Boleh saya continue ke? Macam terpaksa je. Okay. Okay, again, tautology is proposition which is always true. This one you need to develop a truth table first. Okay, and then proposition is must be proposition. Okay, proposition, and then make sure it is a biconditional. Biconditional. Okay. And then secondly is contradiction is a proposition that is always false. Contradict. We have here we have a P or negate. P is one variable. 2 power of 1 equivalent to 2 lah. Okay. Proposition is that always false. Is contradict with the tautology. And then contingency is proposition that is neither tautology nor or a contradiction is neither way lah. Okay, we have a P or Q implies negate R lah. Okay, for the contradiction P and negate P is contradict with this one lah. Okay, okay, this one is neither a tautology nor a contradiction. Okay, this one is different from the tautology and different from contradiction. Okay, we have here we have a variable here. We have 1 and 2, and then we have one variable P and negate P and negate P or 1 also, because we have same P here. Okay, and then when you use to 2 power of 1 is equivalent to 2 lah. Okay, and then we have here P or negate P is always true, is a tautology, and then always false is a contradiction. Okay, please bear in mind when you see the tautology and contradiction is based on the truth table output value. Output value when you compound the statement, when you join the statement. Okay, when you join the statement or you joining the variable. Okay, this one is logical equivalences. Two proposition P and Q are logically equivalent if they have the same truth value in all possible cases. Okay, and then before you said it is a tautology, you need to have if P biconditional Q is a tautology. Okay, we can say the notation is P equivalent to Q or P equivalent to Q. You should put this symbol or this symbol. Okay, you can put one or two. Is sim. Sim. Okay, we have a notation one and notation two is equivalent. Is a sim. Okay. Okay, and then determining the logical equivalences. First of all, you need to use the truth table, truth table, and defining how many variable. Okay, to power of n lah. And then show that the negate p or q and negate p and negate q are logically equivalent lah. Okay, this one is logically equivalent. Not every efficient method. This one is not a very efficient method. Why? Can somebody justify why? Kenapa dia bukan good method? Mai ada Mai. Mai boleh bagi idea. Kenapa? Mai Zatul? Why? Not a very efficient method. Ha? Tak tahu. Apa yang kamu tahu? Okay. Felicia? Why? Why is not a very efficient method? Kalista? Kalista, do you have answer? Why? Yeah, it takes too much time and too much work, and you have to first use the truth value and see the output. Need to evaluate the output and then show some equivalences. Step 2. Basically, you need to have so many steps. Okay, and then for the solution, we develop a series of equivalences. Develop a series equivalences. We develop a law. A law. Okay, in programming, law is the syntax. We call it as a syntax in programming. Okay. Okay, this one is proportional equivalences. True, we name it as identify, identity, domination, idempotent, and double negation. We have four here. One, two, three, and four. Okay, for the identity, for the proportional equivalences, we can say that P and true is equivalent to P. P or false equivalent to P is the true identity. Identity, the important equivalences. Okay. Identity is true place predicate which has a true value if its argument are numerically identical or false otherwise. Okay, this one is true. If we can say this one is true, if the argument are numerically identical, okay, this one identical or false. We have a true or false value. Okay, Is it okay? Oh, boleh ke? Boleh faham ke? Okay, a definition of equivalent relation. This one is to be identity. Identity. Okay. Example: we have P and true is equivalent to P, lah, which are numerically identical, and also you have a second case is false, identical. Okay, and then for secondly is we look at domination. Okay, domination equivalent, or simply we call it as they have the same domination. Domination. Okay, for example here we have a P or true is equivalent to true. Okay, it's same lah, same domination. Okay, or simply we denote that P or true is equivalent to true. Yeah, same goes to the number four. We have P and false. Is identical. The output is false. We name it as a domination. Domination mean all of the output is same for the truth. The output is same, false and false. It is this one identical. Okay, and then we have idempotent. Idempotent. Okay, as you can see here, we have P or P is equivalent to P. Okay, and then P and P is idempotent to potent to also P, which means that denoting an element of a set which unchanged in the value when multiplied or otherwise operated by itself. Okay, by its uh, own variable. For example, here we have a negate p or negate p also. We implies the negate p lah. Okay, and then negate p and negate p also we implies equivalent to negate p. Okay, and important is the series that unchanged, unchanged in value when multiplied uh, uh, and or all. Okay. Okay. Other than that, we can say also when apply to itself, the operation, for example, and or all, a given operation such as multiplication equal itself also an operation under which a mathematical quantity is idempotent. Idempotent, which means the uh, mathematical quantity is equal into itself. Is equal into itself when you do operation. And then the last one we have a double negation. We negate the variable, we negate the propositional, and then as you can see, if you negate and negate p is equivalent to p lah. Okay, it's negative. For example, here, if we negate and negate, we are equivalent to negate p. For example, if we have negative, negative, negative x is equivalent to negative x, because negative and negative is equal to positive, negative positive equal to negative, positive negative equal to negative. Okay, this one is double negation. We double up the negation operation. Okay, and then it is important also you need to know the important equivalences. Okay, for this one we have commutative, associative, distributive, and De Morgan's law. One, two, three, and four. Okay, we have four important equivalences. Commutative. Okay. Commutative property state the number on which we operate can be moved or swapped. Can be moved or swapped. For for these equivalences, we swap without making any differences to the output. Okay. Okay, we swap. We swap the swap the P and Q or negate P. We just swap. We just swap negation here and Q to here lah. And then we can have P negate and negate P. Okay, because we change, and then we have O Q lah. And then this one is the same output. Okay. This one is commutative. Be remember when you want to commutate the equivalences, which means that you need to swap from their position without making any differences to the output. Okay, is it okay, guys? Okay, if okay, we continue to associative. Associative properties that you can add or multiply uh, regardless of the how many numbers are being grouped. For example, here we have P or Q or R. Same also equivalent to P and Q or R. We uh, we group some of the uh, proposition. Okay, this one is for the associative. Okay, example for associative. If you're not clear, this one for associative. Okay, we have 5 multiplied by 4. Okay, we have 5. Okay, and then this one is 20 times 20 is equivalent to 40. 5 multiplied by 8. You just group this one, and then you group this one. This one is we call it as associative property. Okay, is it okay? This one associative. Okay, you want to associate, you want to group, but the output is still same. 40 and 40. Okay, kamu jangan okay ya. Nanti dalam quiz nanti saya akan tanya. In the quiz, I will ask this one. Okay, and then we have distributive. Distribute. You want to distribute. For example, P and Q and R. Okay, you want to P. You open up the uh, bracket. You open up the bracket. You insert the proposition into bracket. Okay, and then we can have P and Q, and then the operation is N. Operation is still same. P or R. Okay, and then also same here. P and Q or R. P. Okay, you put this value inside. Distributive. Okay, distributives. You put the value inside the open bracket. Okay, the law relating the operation of multiplication and addition. Okay, for example, ya saya buat satu lagi lah. Kalau tak kamu tak faham. Okay, this one for distributive. Okay, we have A, B plus C is equivalent to AB plus AC. Okay, this one is for the distributive. Okay, here you want to put the value inside the open bracket and close bracket. Okay, when you say the number 4 is De Morgan law, you want to remove the open bracket and close bracket. For example, here we have a negate open bracket P and Q is equivalent to negate P, but this one change. This one from N to O. For example, here we have negative X plus Y. Okay, tak kalau tak clear, saya buat satu lagi lah. This one is De Morgan. Okay, is equivalent to negative X, negative Y. Okay, is it okay? Okay, the operation here is changed from positive to negative because we put the negative here and then you put here. Same goes to here equivalent. Okay, and then we have negative X and negative Y P or Q equivalent to negate P and negate Q lah. Syawal, okay Syawal? Okay, this one is four important equivalences. Okay, before this we have learned the identity, domination, idempotent, and double negation. And then we continue as commutative, associative, distributive, and De Morgan. We have four plus four is equivalent to eight. Okay, and then here we have P and T is equivalent to P lah. This one is identity, and then we can call this one is domination. P or T is equivalent to true, true. P and F equivalent to false. Okay, same here. Okay, this one true or false is identity. Identity because it equivalent to sim. Okay, identity and domination. Okay, identity is equation which is always true, lah. Always true. No matter what the value substituted, lah. And then it also have the equation which is always false, lah. Okay. Okay, for example, here you have a proposition one and two, lah. True, false. P and uh, T is true. P or false are true, lah. Okay, this one we call it as identity. Okay, is equality relating one mathematical expression. For example, we have A to another mathematical expression B, right? Such as A and B produce the same value for all values of the variable within a certain range of validity. That one is identity, and the other one is domination. Okay, domination in maths. Uh, okay, domination is a highly informal term relating to function. We can say that one function dominates another if the output is same. Okay, as we can see here, P and true is equivalent to true. Okay, P uh, P and false equivalent to false. Okay. Okay, this one is important equivalent. Okay, we have another one, absorption. We want to absorb and negation. Okay, this one same. Same P and P. And then we have the repetitive variable P is absorb. We want to absorb. Same goes here. P and P or Q lah, equivalent to P. This one is absorption. And then negation. Negation when P negate by P is equivalent to true. P negate P and negate P are false. This one is negation. And then for the distributive law, we combine this one, absorption and negation. Okay. Okay, we combine P and Q uh, and R is equivalent to P or Q and P or R. This one is a distributive. Okay, distributive. Okay, this one is distributive. P, O, and N. Okay, we have P, O, Q, and R. Okay, here we replace this one, N. Okay, and then P or Q is here. Okay, P and R is here. Okay, okay, and then distributive N O, P and Q. Okay, this one. Okay, or this one for the operation, we combine P and R. Okay, okay, and then for the last one, P or Q and P or R is we assign as P and Q and R. Okay, this one is distributive. Okay, again, distributive law is the law relating the operation of multiplication, and we add and or operation that distributed separately, or we can combine. This one I have explained it. I have explained this one for the distributive law. No, distributive. Let me say that. Okay, this one distributive. Okay, same. Same here. Okay, this for the distributive. Okay, and then okay, and then distribution and absorption. We want to combine distributive and absorb. We want to absorb. Repeated. This one repeated. Okay, and then we want to absorb. Equivalent to P. This one is absorption. Okay, when you say P or Q and R, this one is distributive. We want to distribute. Okay, P and Q. Okay, and then here and P or R. Okay, I think for the rest of this slide, we have so many